Have you noticed how lithium-ion batteries, the ones powering our smartphones and electric cars, seem to have plateaued? These remarkable batteries, which have driven so much innovation, are now showing their limitations. Their energy density, or the amount of power they can store, has stagnated between 250 and 300 Wh/kg. Essentially, we're discovering that this technology has nearly reached its full potential, especially when it comes to extending the range of electric vehicles. It's like trying to fit more into a box that's already full. No matter how hard you try, there's simply no room left. This poses a significant challenge for electric vehicles, EVs, where the goal is always to go farther on a single charge. Nobody wants to be stuck on the road wondering where to recharge. But with lithium-ion batteries hitting their limits, EV ranges are constrained. Even with advancements in other areas, like more efficient motors or improved energy recovery systems, the battery remains the bottleneck. It's the heart of the system, and right now, it's beating at its maximum capacity. When lithium-ion batteries were first introduced, they revolutionized electronics and reshaped our expectations for EVs. But innovation is relentless, always pushing for more. Today, as impressive as these batteries still are, they can't deliver the leap forward we need to truly unlock the future of electric mobility. Many experts believe we're at a critical juncture. Either we discover a new energy storage breakthrough or accept that current EVs have a natural range ceiling dictated by today's battery technology. So, what's next after lithium-ion? Emerging technologies like solid-state batteries are generating considerable excitement. These promise not only greater safety but also a significant boost in energy density. Imagine a battery capable of taking an EV nearly 2,000 kilometers on a single charge. It sounds like science fiction, but it's closer to reality than you might think. Take, for instance, the groundbreaking work of the Chinese startup Talent New Energy. They're developing a solid-state battery with an astounding energy density of 720 Wh/kg, nearly triple the capacity of today's lithium-ion options. This advancement could transform electric cars, allowing for ranges of up to 1,240 miles, about 1,996 kilometers, on a single charge. That's enough to cross an entire country without even considering a stop to recharge. This breakthrough could eliminate one of the most significant concerns about EVs, range anxiety. It's as if we suddenly unlocked a much larger, far more efficient fuel tank, redefining what's possible for electric vehicles and taking a monumental step toward the future of sustainable transportation. Without relying on fossil fuels that harm the environment, solid-state batteries emerge as a cleaner, safer alternative to conventional lithium-ion technology. One of their standout advantages is safety. Unlike lithium-ion batteries, which, though rare, can overheat or even catch fire, solid-state batteries eliminate this risk. But what makes them so different? The key lies in the electrolyte, the substance that transports ions between a battery's electrodes. In traditional lithium-ion batteries, the electrolyte is a liquid, which can sometimes lead to instability, overheating, or even dangerous reactions. In contrast, solid-state batteries use a solid electrolyte. This simple yet transformative shift not only enhances stability but also significantly improves safety. Additionally, the solid structure allows for a more compact and efficient design, increasing energy density. With this innovation, the same-sized battery can hold far more energy, fundamentally changing the landscape for electric vehicles, EVs. Range anxiety has long been a hurdle for EV adoption. No one wants to spend hours at a charging station during a road trip. However, solid-state batteries with an energy density of 720 Wh/kg can revolutionize this experience. These batteries could power an EV for several days or even weeks under normal usage before requiring a recharge, a massive improvement over current lithium-ion technology. Durability is another game-changer. Lithium-ion batteries degrade over time, gradually losing their ability to hold a charge. Anyone who has owned a smartphone for a few years knows this frustration. Initially, the battery lasts all day, but after a while, it dies halfway through. This degradation also affects EV batteries, reducing their range over time. Solid-state batteries, however, degrade much more slowly. They maintain their capacity and performance for far longer, providing a longer lifespan and reducing the need for frequent replacements. Of course, cost is often a concern with new technology. Solid-state batteries will initially carry a higher price tag. However, as production scales up and more manufacturers adopt the technology, prices are expected to drop, making them competitive. Given their superior efficiency, longevity, and safety, the long-term cost benefits will likely outweigh the upfront investment. The potential of solid-state batteries goes far beyond EVs. Imagine their application in industries like aviation, where electric planes could travel long distances without burning fossil fuels, or in consumer electronics like smartphones and laptops that could run for days or even weeks on a single charge. This innovation has the power to transform how we store and use energy in countless aspects of daily life. One of the most exciting aspects of solid-state batteries is their unparalleled safety. Unlike traditional lithium-ion batteries, whose liquid electrolytes can be flammable and prone to overheating, the solid electrolytes in these batteries are far more stable. This greatly reduces the likelihood of fires or explosions, even under extreme conditions, providing greater peace of mind especially for EVs, where safety is paramount. Additionally, solid-state batteries boast exceptional durability. While lithium-ion batteries lose performance over time, solid-state alternatives degrade at a much slower rate. This means they retain their capacity for significantly longer, a major advantage for devices and vehicles that are used heavily every day. Perhaps the most impressive feature is their energy density. Solid-state batteries can store far more energy than lithium-ion ones, paving the way for longer-lasting and more efficient energy solutions. This combination of safety, durability, and high energy capacity positions solid-state batteries as a transformative force across industries, from transportation to personal electronics, shaping a cleaner and more sustainable future. Solid-state batteries are set to redefine energy storage by packing far more energy into the same space. For electric vehicles, EVs, this is a game changer. Imagine traveling hundreds or even thousands of kilometers on a single charge without needing to stop for recharging. This breakthrough could dramatically extend vehicle range, alleviating concerns about running out of power on long trips. But the impact of this technology doesn't stop with cars. It has the potential to revolutionize many other industries. Take drones, for example. With solid-state batteries, they could fly for much longer periods without needing to return to their base. Similarly, smartphones and laptops powered by this technology could operate for days or even weeks on a single charge, transforming how we interact with our electronic devices. Moreover, the longer lifespan of these batteries addresses a critical environmental issue. Because they need to be replaced less frequently, they generate less waste, contributing to a significant reduction in electronic waste and making them a more sustainable choice for our planet. Safety is another key advantage. Unlike traditional lithium-ion batteries, solid-state alternatives pose a much lower risk of fire or explosion, simplifying transportation and storage requirements. This not only enhances safety but also reduces the need for expensive safety measures, making the technology more practical for widespread use. However, the journey to making solid-state batteries a market reality isn't without its challenges. Large-scale production at a competitive cost remains a significant obstacle. Currently, manufacturing these batteries is more expensive than producing lithium-ion versions. But as with most technological advancements, economies of scale and further refinements in production processes will likely bring costs down over time. This mirrors the trajectory of electric vehicles, which were once prohibitively expensive but are now becoming more affordable. Major companies across the automotive and tech sectors are racing to lead this innovation. Automakers like Toyota and Volkswagen are heavily investing in research to incorporate solid-state batteries into their vehicles. Meanwhile, startups and tech giants are also vying to be the first to introduce a viable, cost-effective version to the market. This competitive landscape marks the beginning of a technological revolution that could redefine how we think about energy storage. What makes this development so groundbreaking isn't just the increased energy capacity, it's the fundamental redesign of the battery itself. By replacing the liquid electrolyte with a solid material, solid-state batteries offer significant advantages. They are not only safer, with a drastically reduced risk of fire or explosion, but also far more efficient in utilizing stored energy. This combination of safety, durability, and efficiency positions solid-state batteries as a transformative force across industries, paving the way for a cleaner, more sustainable future. Imagine a vehicle capable of traveling over 1,200 miles or nearly 2,000 kilometers on a single charge. This isn't just a slight upgrade, it's a revolutionary leap forward in battery technology. But it's not just the extended range that sets these batteries apart. Durability is another standout feature. Unlike traditional lithium-ion batteries, which gradually lose their ability to hold a charge over time, the new solid-state batteries developed by Talon New Energy are designed to maintain their performance for much longer. Even after years of daily use, such as in an electric car, these batteries retain a significant portion of their capacity, making them a game-changer for EV longevity. Another aspect that often goes unnoticed is the impact on charging times. Solid-state batteries have the potential to drastically reduce charging durations, and Talon New Energy is actively exploring this advantage. Imagine recharging your electric car in just minutes instead of hours. This improvement not only makes electric vehicles more convenient for daily use but also addresses one of the biggest barriers to widespread adoption, the time it takes to recharge. By solving this issue, the technology could significantly boost consumer confidence and accelerate the shift to EVs. The development of Talon New Energy's prototype offers immense promise for the global adoption of electric vehicles. Many consumers are hesitant to transition from combustion engine cars due to concerns about range, safety, and cost efficiency. However, with batteries that can handle long distances, last longer, and are safer than their predecessors, these challenges begin to fade. On the environmental front, solid-state batteries offer even more benefits. Lithium-ion technology has been criticized for its environmental impact, from the extraction of raw materials like lithium and cobalt to the challenges of recycling spent batteries. Solid-state alternatives not only last longer, reducing waste, but they can also incorporate less harmful materials in their production process. Talon New Energy is prioritizing sustainability in their manufacturing approach, aiming to minimize environmental harm and create a greener production cycle. Although this innovative battery prototype is still under development, it's already capturing the attention of the market. Major electric vehicle manufacturers are forming partnerships and making significant investments in solid-state technology. After all, being the first to deliver a car with a battery that boasts longer lifespan, faster charging, and unparalleled range could provide a decisive competitive edge. For automakers, this advancement represents the perfect opportunity to dominate the rapidly growing EV market, setting the stage for an exciting new era in sustainable transportation. In the years ahead, what could all of this mean for the future? If Talon New Energy continues to innovate at this pace, these batteries are likely to redefine not only electric vehicles but also the broader electronics industry. From smartphones that could last several days on a single charge to drones capable of flying for hours, and even portable medical devices that operate for extended periods without recharging, the potential applications are transformative. What's particularly exciting is how even a smaller 50 kilowatt-hour battery could deliver incredible performance. For instance, such a battery could provide an EV with a range of around 500 miles, over 800 kilometers. This would easily cover the daily driving needs of most people, eliminating the constant anxiety of finding the next charging station. Imagine a Tesla Model 3 or Model Y traveling that distance on one charge, making long trips seamless and stress-free, without the need to plan frequent stops for recharging. This innovation would not only benefit long-distance drivers but could also unlock opportunities for EVs in remote areas. Currently, one of the biggest challenges to EV adoption is the lack of charging infrastructure, especially in rural regions or developing countries. With batteries like these, the reliance on frequent charging stations would be significantly reduced, making EVs a practical option even in areas without robust charging networks. Now, imagine Tesla integrating this cutting-edge battery technology into its vehicles. It wouldn't just be about range anymore, it would also revolutionize charging times. These batteries, with their ability to store more energy and charge faster, could make Tesla cars virtually unbeatable. Waiting 30 minutes or more at a supercharger could soon become a thing of the past, as these batteries promise to cut charging times to mere minutes. This would make the transition to EVs far more attractive for consumers still hesitant about charging delays. Additionally, the efficiency of these batteries could enable Tesla to redesign its cars. A smaller 50 kilowatt-hour battery could still cover most daily driving needs while making vehicles lighter, more efficient, and potentially more affordable. Smaller, lighter batteries would also require fewer raw materials, aligning perfectly with Tesla's commitment to sustainability and reducing the environmental footprint of EV production. For Tesla, this would be more than just a technological upgrade, it would solidify its leadership in the EV market. Competing automakers would face immense pressure to catch up, scrambling to invest in research and development to match Tesla's capabilities. This could widen Tesla's market advantage, making it even more dominant in the global EV landscape. Beyond personal vehicles, the implications for freight transport are equally groundbreaking. Electric trucks like the Tesla Semi could cover enormous distances with this battery technology, transforming the logistics industry. Faster charging would minimize downtime, allowing long-haul trucks to remain on the road longer and reducing operational costs for logistics companies. The promise of fast charging, think 80% in just 15 minutes, represents a game-changing convenience. Solid-state batteries achieve this thanks to their high ionic conductivity, allowing ions to move rapidly within the battery. This dramatically cuts charging times compared to traditional lithium-ion batteries. Imagine stopping at a station, grabbing a coffee, and in the same time, having your car ready for hundreds of miles of driving. What's more, this technology doesn't require large batteries to deliver results. Even smaller, more affordable EVs could benefit from super-fast charging, making electric cars more practical and appealing for everyday use. This would further ease the transition away from combustion engines, resolving one of the main concerns consumers have about EVs, charging convenience. Solid-state batteries also represent a major step forward in safety. By replacing the liquid electrolytes used in lithium-ion batteries with a solid material, the risks of leaks, fires, or explosions are greatly reduced. This combination of faster charging and enhanced safety could redefine how consumers view EVs. The benefits don't stop at vehicles. Fast-charging solid-state batteries could revolutionize other industries as well. Think of mobile devices like smartphones, laptops, or portable medical equipment. Charging them in just minutes would transform how we use and interact with technology in daily life. Gone would be the days of waiting around for devices to charge. Returning to the automotive world, the impact on autonomous driving could be profound. A fleet of Tesla robot Axis, for example, could recharge quickly between rides, maximizing efficiency and reducing downtime. This would make autonomous transport services more accessible and reliable, further accelerating the shift to mass adoption of self-driving vehicles. Finally, the introduction of this solid-state battery technology would inevitably shake up the EV market. If Tesla or any company implements this innovation, competitors would be forced to either keep pace or risk falling behind. This pressure would likely ignite a new wave of advancements, not just in battery tech but across the entire EV supply chain, driving the industry forward in ways we can only begin to imagine.